In the following video, I would like to talk to you a little bit about the difference between concept modeling and technical surfacing. And the main difference between those two approaches is that, for example, in concept modeling, we very often create surfaces by maybe utilizing hand-drawn curves and picking edges from trimmed surfaces. And in technical surfacing, we basically recreate the curve layout and create the surfaces by not using trimmed edges. The main reason why not to use trimmed edges is trimmed edges are heavily parameterized. That means there are a lot of spans on it. So the geometry count is very high, which can make our work afterwards more difficult. So let's take a look at what all this means. I have here a curve layout and I'm creating a very simple rail surface, and then I'm going to project my trim line on it, and then I'm going to trim off this upper part. Okay, so that doesn't look too bad. And then for a quick study, I could select this trimmed edge and click my upper curve and create the next rail surface. However, if you now compare those two surfaces, you can clearly see that the upper surface that is created by using a trimmed edge has a different geometry density than, for example, the lower surface. And if we select both surfaces and then turn on the display for the CV and the hull, you can now clearly see that the upper surface is a lot more subdivided. So for example, if I click this one, you can see that it has 10 spans, and if I select this surface, you see this one has only one span. And spans in general are something you want to minimize on surfaces because they can be quite problematic for the curvature flow. To understand actually where those spans actually come from, let's actually backtrack for a moment. I'm going to put this one onto this layer. Let's go into side view, and I'm going to untrim the surface. So if you now take a look at that trim curve, which is the line we projected over this rail surface, you can see how many spans actually that line needed to have so it could basically be projected over the surface so that it accurately lies really on the surface and then can be used as a trim curve. But it also means that it will add a lot of geometry, which we necessarily don't really want to use. So what is now a different approach how to create an upper rail surface which is equal to the first rail surface? So if we go back for a moment and take a look at this curve, you can see that it is a degree 5 and it has one span. So this is, for example, good to know. And then let's go to our surface. And you're familiar with the duplicate curve. The duplicate curve tool, for example, copies out the trimmed edge, and here we see that it is a degree 5, but it has 5 spans. So that is the problem why our rail surface from the trimmed edge is so heavily parameterized. So that's not really what we want to use. Instead of using the duplicate curve, because that only copies out or extracts the existing trimmed edge, we would like to rebuild this edge best as a degree 5 curve with one span. So if you click on Fit Curve, you can define the degree and the spans, and I put in exactly the same numbers as, for example, for the original curve on the bottom. And then you can click on an edge. An alias then is rebuilding a curve and positions all the CVs for you so that the curve really will follow your trimmed edge as closely as possible. If you only would like to, for example, extract half of it, or like a custom shape, you have start and end sliders. You can position. In my case, of course, I would like to have the complete trimmed edge extracted. And if I zoom in a little bit, you can see that this really fits nicely. If I, for example, just play with the numbers, you can see that alias, well, with 3, of course, it doesn't work, and 3 might not be enough. 4 will start to work. 5, of course, will work because it's the same amount of points. It repositions all the CVs for you automatically so that the curve that is being created inside will fit your trimmed edge. Okay, so with this curve actually created, we can now go ahead and go to the rail command again. Then I select my fit curve and not my trimmed edge, and then select the upper curve. And if we now go ahead and turn on the CV in hull, you can see that those surfaces are a perfect match. So the distribution of my CVs across the surface for both is equal, which means if at one point I would like to custom work or position some of the CVs, I have exactly the same amount of points, which means if I would like to do something for a lower surface and I would like to do the same exactly to the upper surface, I don't have to maybe interpretate between different CV densities. For example, in this case, I could simply select, let's say, those 2 points and those 2 points. And if I push those here, maybe let's say this direction and those points into this direction, I know that the geometry I will create for both surfaces will basically be the same. And also in general, the quality will be better. So if I, let's say this sharp edge, later I would like to fill it, alias is going to work on 2 surfaces which also have a similar geometrical character. And that is always something that makes it easy for alias then to calculate the surfacing tools. Because the denser a surface might be, the more difficult also, for example, then a command could be for alias to apply, and then the resulting quality of the surface. And that is basically what you can use the fit curve tool for. So you recreate edges, trimmed edges, create new profiles from it, and use then those for your surfacing commands.